Okay, so we need to finish up these. So Lewis structure for hydrogen sulfide, H2S. So which element should be central? S. What? We didn't. We did H2S together?
Yeah. Why do I have it right here then?
I think you might have worked ahead. I don't think we did it together.
I might have worked ahead.
Yep. I guess first we should add these up. So we have, and I need to make sure I have the right. So we have 2 times 1 plus sulfur has how many? 6. So we have a total of 8. So we said sulfur should be in the center and hydrogens on each side. Doesn't matter which side hydrogens are on. We'll learn later how it should look, but that'll be next chapter, I think. So sulfur has 6. Let's put in the 6. And the 5th and 6th dot we're probably going to put on top and bottom because we know hydrogen's going to donate 1 on each side. So we'll put those 2 there. And now we have 2, 4, 6, 8 dots, which is how many we added up. So let's draw the dashes in. Check the octet. Sulfur has 2, 4, 6, 8 valence electrons now. Hydrogens each have 2, so everything's stable. And that would be our structure. Okay, the next one's CH2O. So carbon has how many valence electrons? And hydrogen has 1 each. Plus oxygen has, so we have a total of 12. Should erase this. Which element should be in the center? Carbon, right? So let's put our hydrogen, and oxygen. So we said carbon has 4. 1, 2, 3, 4. Each hydrogen donates 1. And oxygen has 6. 1, 2, 3, 4, 5, 6. So now let's count our dots. 2, 4, 6, 8, 10, 11, 12. So we have 12 dots. So now we're supposed to change these into dashes here. Now let's check our octet. We know we have the right number of electrons drawn, but let's check our octet. 2, 4, 6, 7 for carbon. 2, 4, 6, 7 for oxygen. Are there octets full? No. So in this case, this carbon needs 1 more. This oxygen needs 1 more. So what's going to happen is these 2 electrons right here are going to also be shared in with this bond between them. So let me erase those 2. So they're getting shared, so we're going to put them in the bond. And now what kind of bond is that? A double bond. That's how we form double bonds. So the double bond has 4 electrons being shared between the carbon and oxygen. Now this carbon has 2, 4, 6, 8 electrons around it. Oxygen also has 2, 4, 6, 8. So by each of them sharing an electron with each other, they're able to be stable, have an octet. Now there'll be some times, once in a while, you'll want to make a double bond with 2 electrons from the same atom instead of taking one from different atoms. You can share 2 from one atom with another. Yep. So questions on that one? Okay. Quiet bunch this morning. Said you're a quiet bunch this morning. Carbon dioxide. So carbon has how many valence electrons? Oops, just a second. 4 plus 2 times 6. So that's, yep, oops, 16. Which atom should be in the central? Carbon, and then there'd be 2 oxygens. So carbon has 4 valence electrons. There's 4. Oxygens have 6. So there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So let's count our dots. We have 2, 4, 6, 8, 10, 12, 13, 14, 15, 16. 16 dots, so we're good with electrons. We can't add or subtract anymore. Now let's change these to dashes and check octets. Now, do each of the atoms have an octet? No. 2, 4, 6, 7, 2, 4, 5, 6, 2, 4, 6, 7. So each oxygen needs 1, carbon needs 2. What do you think we're going to do? So like this one and this one are going to form a double bond right here. And then this lone electron on carbon with this lone electron on oxygen form a double bond right there. So there's 2 double bonds. Hydrogen cyanide, so known as cyanic acid. So hydrogen has 1 valence electron, carbon has 4, nitrogen has 5. So we have a total of 10. Which element should be center? Carbon. So it's basically written out just how that formula looks. So hydrogen has 1, carbon has 4, nitrogen has 5, 1, 2, 3, 4. Doesn't matter where you put the 5th one, I'm going to put it right there. So count our dots. We have 2, 4, 6, 7, 8, 9, 10. 10 dots. Good. Draw our dashes. Now our octet's full. We have 2, 4, 5, 6, and 2, 4, 5, 6 for both. So both atoms need 2 electrons. Where are we going to get those atoms, those electrons? Those 2 will come in here and bond. These 2 will go in there and bond. So our final so we're sharing a total of 1, 2, 3, 4, 5, 6 electrons. So we need 3 dashes, a triple bond. Okay, I'm going to, let's say Valley's group, you do the CH3Br. Sid's group's going to do C2HCl. For that one, your carbons are going to be next to each other with hydrogen and chlorine on either side, just for a hint. Cyrus group has SiCl4, and Derek's group has F2O. How about I draw up IBR? It's going to be a simple one. Okay. So there's IBR. And then one person from your group can write up your... So for this one, you're going to have, it will look like this. Oops. 2 carbons next to each other. Yep. Just fill in your dots. You should only have 14 electrons. 2, 4, 6, 8, 10, 12, 14, 16. I see 16 electrons. Everyone has IBR written up so I can clear it. Don't make a double bond. 14. Yeah, you had 16. But now do you have an octet around carbon? I see 2, 4, 6, 8, 10, 12. You have 12 electrons around carbon.
Taking a gander.
Okay, so this is the C2HCl. Hydrogen can only have 2 electrons.
Okay, I'm wrong then.
And you have 4 around it.
There you go.
Yeah. You want to just clear the whole. Use that. See that X right there? That clears the page. So the carbons each need 8. Hydrogens can only have 2.
Why?
There's.
Carbon only has 4 up there.
This is like the screen, so if you want to write on the lower right, you have to write in the lower right. It's not like a mouse.
So would they be double or triple bonds on this one?
Possibly.
I thought it was on my paper.
You can have 16, so you have 2, 4, 6, 8, 10, 12,
You can't have 2.
16. It's not quite right. I don't know. Let's. Chlorine now has 2, 4, 6, 8, 2, 4. That's not right, but I can't say, yeah. 2, 4, 6, 8, 10, 12, 14, 15, 16, 17. You can only have 16. I think you have the wrong number of dots. if I counted them right, because there's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. No, you have 16. Anyone else from that group want to?
I have it, Reagan. Come look at it. Make sure it's right. No, it's gonna be wrong. I don't know what to do. I just kind of have crap. No?
Right, it's right, but you gotta make it your octets.
What are the octets though?
This carbon needs 8, and this carbon needs 8. So this one should look like.
Did she have it? I counted 8 for each other.
Yeah, but some, because it should only be. I don't know how. It should look like this.
Don't shout at your ball.
So I think.
And that carbon only has 6.
Oh, triple bond. All right, 16 electrons. 2, 4, 6, 8, 10, 12, 14, 16. So let me, with 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So this is what you have written down, Easton. Right?
Yes, ma'am.
Okay, so now these electrons right here, 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 and here, those 4 all go in here and form a triple bond. That's how we get the triple bond. What one? Now it is. Now a carbon has 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8.
I want to do it. I actually got that one right.
Technically, that's
I know. I need to. How did you get that though? I don't know how you got that. Two, 4. Seeing. I can see where you get that though. Because your numbers are all right. It's. I would probably count it right, like on the quiz, just because everything number-wise is right. But really, halogens can only form a single bond. They can't really form double bonds. You don't really ever see them form a double bond. So. I don't know if I've ever seen anyone do that one that way. Yep, I would agree. That looks good. CH3Br. SiCl4?
That's really why you get him on. I think it was. It's all like a good hour as possible. Who is drunk? He's doing that on that and it still looks better. Are those D's or is that chlorine?
It's chlorine. Sometimes it just freezes. Oops.
Durabrium. Dinosaurium. Shut up.
The 30th. Yeah, next week we'll take a couple days in class to work on them. November 30th is when your element projects are going to be due on November 30th, just so you guys know. I have parent signature forms if you need them. to check out a flip. Okay, if you want to check out a video camera, flip.
I can't even read what that says.
And then, yeah, next week we'll for sure have 2 days in class to work on them. Hopefully you have something to edit by then, by next week. At least a little bit. Or you have an idea of what you're going to videotape, so maybe you could do some videotaping next week. I don't know. Okay. Yep, give it to the next group. Next group.
Is that right?
Yep. Yep. Single bonds between all the chlorines with each chlorine has 6 dots around it also. On the left, you see that X.
Whoa. Can you move like out of drawing? Just get really close to it.
Don't push on it.
I'm not.
Okay, there you go.
See, it's drawing. I'm not even pushing. Wow, you're crap. She says guilty. I don't. A T school cannot be touched. It's possible. Yeah, guilt.
Think Giltner's going to beat Howells?
I don't care. Giltner can beat us.
Giltner's pretty good, but aren't they 8-man? They wouldn't have enough people.
Giltner's lower than Giltner's easy. What is this, Derek? Where is S on this thing? It's right there.
Yes, I'd agree. Howells. They've won the state championship like a lot of years. That's who they lost to in the state championship last year. That's who they play next, I think. Okay. Now, we're going to do the same sort of thing. Whoops.
What was that? You know who we played Friday?
McCook.
Number 1 team state test.
Polyatomic ions. Polyatomic ions are charged groups of covalently bonded atoms. So we're going to have a group of atoms, but instead of being neutral, they have a charge attached to them. So they have extra or fewer electrons. They will combine with other ions to form ionic compounds. So when we draw a Lewis structure for a polyatomic ion, we're going to either add or subtract a number of electrons depending on what the charge is. Then we'll place brackets around the structure and show the charge outside of the brackets. But everything else will be the same. So if we have a 2- charge, have we added or subtracted 2 electrons? 2-. We have 2 extra electrons, 2 extra negative charges in order to give it to 2- charge. So we've actually added electrons to it. So it's kind of backwards. Even though it says 2-, we've added electrons to it. If it's 2+, we have 2 more protons. We've taken away electrons to give us more protons and electrons. So if it's 2+, we would have taken away 2 electrons. So let's, what in the world? So we'll draw Lewis structures for these polyatomic ions. So NH4, let's add up our electrons first. Nitrogen has how many valence electrons? 5 plus 4 times 1. And then what does that plus sign mean? We took away an electron, so we're going to take away 1. So how many total?
8.
So now we have NH4 because it's plus 1. If it's plus 2, we take away 2.
It's plus 1, huh? How do you know it's plus 1?
It says plus on there.
There's no 1?
plus means plus 1. If it was plus 2, it'd have a 2 behind it.
Okay.
Just a plus means plus 1.
So plus means minus plus. So the 2 would be in front of the 4. So like on the
Yeah.
SO4 2 minus.
Yeah, and there should be a 2 right there.
Scientists
So-
are stupid.
So nitrogen has 5. 1, 2, 3, 4, 5. Hydrogens each have 1, 2, 3. Nitrogen? Nitrogen has 5. Well, we haven't subtracted 1 yet. Okay, so we have all of our electrons drawn, but we need to subtract the 1. Where should we subtract the 1 from?
The left on top from hydrogen.
This one. It should be pretty obvious.
Go, guys.
There we go. So now we can draw in our bonds. This should be, oops, right there. So there's our Lewis structure. Now to finish it off, since it's a polyatomic ion, we need to put brackets around it and put the charge outside. So that way we know what we took away, an electron. We have a plus 1 charge for that whole thing. Because it should be 2 minus. On your sheet it says 2 minus. Up here the 2 didn't get transferred. So for SO4 2 minus, this should be minus 2.
Plus 2.
For polyatomic ions, you always just put brackets around it to show the charge and to make sure you know it's a polyatomic ion. So sulfur has 6. So does oxygen, right? 4 times 6. And then the 2 minus means we add 2 more.
To everything.
So what's our total there? 32? Yep. So which element do you think is going to be in the center? Yep. And so we have 4 oxygens around it. 1, 2, 3, 4, 5, 6 for sulfur. So this is a case where sulfur is going to share 2 electrons with the oxygen. And let's fill in the rest of the 6 oxygen electrons. 1, 2, 3, 4, 5, 6. So none of the electrons from oxygen is getting shared with sulfur, but sulfur is sharing 2 of its electrons with oxygen. In this case, 1, 2, 3, 4, 5, 6.
Sulfur only has 4 in that picture.
No, it had these 2, 1, 2, 3, 4, 5, and 6.
How do you know it shares 2?
Because when like sulfur would have, because it has so many, like when you just draw the structure.
What if we added dots on top of other dots? Yeah. Just add
Other dots on top of dots.
You always put them side to side, right? They're side to side. On top of each other. Where?
Like this. Just because I knew they were going to bond with the oxygen. That way it's easier to draw the dash. So sulfur, since it has 6 right here, but it has to have 4 oxygens around it, 2 of them have to be shared with one of these oxygens. So now if I add my oxygens, there's already 2 there. So I don't want to add a 3rd one in there because you don't share 3 multiples of 2 you share. Okay, so now we need to add 2. Where should we add 2 electrons? We get to add 2 anywhere. Where would be the best place?
Left, right.
Oops. This one needed one more.
Oxygen.
Right here and right here. There are 2. So we should have an octet around all of them. That's a single bond, not a double bond. Yep, there's an octet around all the elements. So now to finish off a polyatomic ion, you always just put the brackets around it and put a 2 minus. PO4 3 minus. Ooh, what's the 3 minus mean? We had 3. Phosphorus has 5 valence electrons plus 4 times 6 plus We're going to add 3 this time. So we again have 32, right? 33? 32. Phosphorus will be in the middle. Oxygens on each side. So phosphorus had 5. 1, 2, 3, 4. Now this is another case where I need to add a 5th electron on phosphorus, so it's going to share 2 with one of these oxygens. It doesn't matter which one, so we'll just put it right here. So now this oxygen, when I put the 6 around it, 3, 4, 5, 6, it's already full with an octet. These oxygens, the other 3, need to share 1 electron with phosphorus. 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then we get to add 3 anywhere. Where should we add them? This one only has 7, so I think this one needs 1 more to get an octet. This oxygen needs 1 more electron to get an octet, and this one needs another oxygen, or another electron to have an octet. So now all the oxygens have an octet, the phosphorus has an octet. So we put our brackets around it and put our charge. The last one, CO3 2 minus. We have 4 plus 3 times 6. And what that 2 minus tells us we do what? Add 2. So we'd have 24. 3 oxygens. It doesn't matter which side the oxygens are on. 4 dots for carbon. And then each oxygen gets 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then we get add 2 anywhere. Where should we add them? I'll give you a hint, not carbon. It'll just make things simpler if you add the oxygen or add the extra electrons to one of the elements that are on the outside. It'll make things a little easier for us. So now we draw on our bonds. This oxygen has an octet. This oxygen has an octet. This one only has 7 and carbon only has 7. So what do you think we're going to have to do here? Throw them both in here and form a double bond. So we'd have a double bond right there. Now carbon has an octet and that oxygen has an octet. Finish off the polyatomic ion, you always have to put the brackets with the 2 minus. There you go. Okay, let's